So taking a look at some examples of materials that CHS has created in the past. So a wide variety of silicon nanostructures can be made. So silicon quantum dots with well-controlled size, silicon thin films, so with well-controlled not only particle size but packing into the thin film, so having appropriate voids in the thin film for wetting by electrolyte and things like that, as well as silicon nanowires. So just going back to the silicon nanowire example, so that they can be made with diameters less than 100 nanometers. And so this 100 nanometers, or actually below 150 nanometers, is critical to one thing that's been a challenge in the past with silicon-based materials in anodes is that the volumetric expansion leads to rapid loss of cell stability but because CHS leads to materials that have well-defined size and morphology, we can avoid a lot of these issues by making these nanoscale materials. And these silicon nanofibers can be made in a highly scalable process. Yeah. So we see here, and this is, I should preface this by saying this is very early work, so no optimization has been done. And so we see here that silicon nanowires, so bare silicon nanowires have a very high capacity. So this is almost a factor of 8 higher than graphite at a modest charge and discharge rate of 0.2 C. So we see here good cycle life over the first 20 cycles, and then a decrease in the overall capacity. So more work needs to be done here, but the thing I'd like to point out is that the Coulombic efficiency of this process remains high.